Good afternoon, ladies and gentlemen, and good afternoon, esteemed speakers and audience. Let me just share my screen first.
Also make it into a slideshow, sir, from the display settings. From the display settings, this on top on the left, second, next to it. Display settings. Yeah, display settings, just click on that, sir. Next to show taskbar. Next to it, yeah. Display settings. You'll have to remove the pointer, I guess, because the pointer is on, you're not able to click on that. Now just go to display settings. On top, sir. Top left one. Top left. After taskbar, the next one. Display settings, just click on that and you can copy, you can set it from there. Just click on that. Next to it, on the right. Display settings, which is right on the right of show taskbar.
No, for some reason it does not show up in my screen, so that's why it's.
We can see it here from on your screen.
Yeah, correct, but it's not showing up on my screen for some reason. So just give me a minute, please.
Sure, sure.
Doesn't display it now. Oh, okay, it's coming there.
Okay. Yes. Duplicate slideshow.
Okay. Is it okay now?
Yes, sir.
Okay. Okay, I need to get some IT help to do that. Again, sorry about that. Let me straight away go into the presentation. So the topic I'm talking today is next generation valves and actuators, reliability and performance. I've been with Emerson for the past 25 years in various functions and roles, primarily in Middle East and Africa. So I moved back to India about 4 months ago. So right now my role is like heading the control valves business for Emerson in India. Yeah. Again, thanks for this opportunity to present this topic. So let me, before we go into next generation, I just want to touch upon the history of valves. Now, if you go back, valves have been used right from the Roman era, like, which is what we are talking about is 2,600, 2,700 years, right from 700 BC, Romans developed valves for use for controlling the flow of water. Then if you fast forward, to the Industrial Revolution days in 17th or 18th and 19th century, valves became more prominent because once a steam engine was developed, you had more and more use for valves. Again, if you fast forward into the 19th century, late 19th century, a gentleman called William Fisher invented the first constant pump pressure governor valve, which later evolved into the current control valves and regulators which are used in process plant. Then again, if you move into the 20th century, there were a lot of new design techniques, manufacturing, availability of exotic materials like a duplex, inconel, Hassler-C materials, which made it possible for valves to be used for extreme pressures, pressure drops, and temperatures. And then valves became like the final control elements in all the process plants. And then if you again look at the last century, in the last decade of the last century, there was another innovation called digital valve controllers or smart fasteners, which again made it possible to remotely communicate with control valves and SIS valves, and they also use diagnostics. Again, another leap in development in terms of the valve industry as such. Now, that's kind of the history and the evolution of valves if you go from Roman era to the last century. Now, even now the speakers before me, the eminent speakers before me, talked about some of these subjects which are like the global priorities and focus. So you look at decarbonization, reduction of greenhouse gas to environment, human health and safety, digital transformation, Internet of Things. These are all the global priorities and focus now. So in my view, the next generation of valves and actuators will evolve with all this in mind, and to improve the reliability, safety, and performance of process plants. So all these are the global focus, and then based on these priorities, the valve and actuators also will evolve. Okay. If we move to the next, again, I just want to give a quick snapshot of the different types of valves and actuators used in the industry now. So if you start from the left, there are the isolation valves, which are typically manually operated. So you have the normal globe ball valves, the gate globe check, and also the butterfly valves, which are used with typically hand wheels. And then if you move to the next right, you have got actuators, which are either pneumatically operated, hydraulic operated, or also electrically operated. And when we integrate those actuators with isolation valves, they become what we call automated isolation valves. Those are all used for either on-off or discrete applications to shut down a process. And then again, you can have a pneumatic isolation valves, or same way electrical as well as hydraulic isolation valves. Then again, if you move to the right, you've got safety valves or pressure relief valves, ASPE certified. Again, those are like overpressure protection or the last line of defense in a process plant, for venting or relief process. Then you also have regulators, which are again similar to safety relief valves, but they don't. They are more for self-actuated, or it could be also pilot actuated. As you can see from the pictures there. And then on the last segment on the right is the control valves, which are throttling for applications, not primarily for throttling applications. This could be throttling process fluid, either for pressure control or temperature control or flow control. Again, different type of control valves in terms of globe, either rotary, ball, butterfly, segmented ball, and also it could be also large angle valves. So different types of valves used for different functions and purpose in process industry. And then you could have a valve which is probably just costing maybe a couple of $100. The control valve at the bottom, which you see the right, those are angle valves, special control valves, typically used for anti-surge applications in special materials and things like that. Those could even cost more than $1 million. So it's a wide range in terms of price, and also they again used for different applications. So if you move on and then look at a particular industry, so I picked one. So valves and actuators, these are the final control elements for process industry. So if I look at just a gas production, production plant, it could be either an offshore or onshore production. Then the gas comes to a processing plant. From there, it goes to a compression station, goes through pipeline to which becomes a feedstock to downstream petrochemical plants. or also for city gate applications, which could be also for the smaller industries or feeding to the other auxiliary industries in a area. Or it could also, we could also compress it and cool it and then ship it as an LNG. But then you look at the various subsystems within that particular plant, and then you look at, for every subsystem, you have to use a valve as a final control element. It could be either for on-off application or control application or a relief application, or for overpressure protection, flow control, pressure control, temperature control. So there are various applications which valves do with various types of valves. If you look at that table on the right hand side, it kind of describes the various subsystems in an offshore platform and what are all the functions which the valve provide. And this is same with any other industry. It could be a steel industry. This could be a petrochemical industry or refinery. You will find that the valves and actuators are the final control elements for the process industry. So this is like some of how the history of the valves, how it has evolved in the last so many centuries. What are the functions what the valves do? What are the different types of valves which are being used in the industry today? Then, I also mentioned in my first slide about what are the global focus and priorities. So let's kind of discuss that in a bit in detail. So if you look at, I've segmented that into two. One is what we call decarbonization, environmental health and safety. Then what are the requirements? Like probably you should have zero or low emissions to environment, low leakage or discharge to environment. Then the other thought is like why do we have people in the process plant? Because when you have more people, obviously it becomes a health and safety impact. So there are now even like some of the remote platforms which are operated without humans. But again, in the future, probably that's a need. Like, we have to have reduced number of people in the plant. Reduce the power requirements in a plant. You use solar power, carbon capture and storage, green hydrogen. Even the gentleman before me talked about hydrogen. So again, green hydrogen. Again, these are all the priorities now. Globally. And if I move to the right again, there is a lot of discussions about digital transformation, Internet of Things. And a subset under that, like additive manufacturing. Again, process plants without people, I talked about in the left-hand side. What about connected intelligent factories for manufacturing the products? AI and robots, another topic. Virtual inspections, remote inspections, wireless monitoring control, diagnostics, prognostics. There's a lot of talk of prognostics now because, if you can get an advance notice of an event before it happens, that helps the plant. So these are all the global priorities and discussions ongoing now, based on which also the valves will evolve in the future. Some of those are already being adopted with some by some of the valve vendors, and again, some are already adopted. So there are two segments to this. One is like in manufacturing the valves. Some of these will be some of those activities will evolve based on these priorities, and also once the valves are installed in the plant, how these technologies can impact and improve the reliability, safety, and performance of the plants. So let's look at some of these, which are available, and some are possibly future solutions. So let's look at first low emissions and discharge. Again, if you look at the plant, the process plant, typically, there are fugitive emissions which happens in a plant, and with the current focus on, reducing the emissions. India is also part of the 2016 Paris Climate Agreement. So there is a directive to reduce emissions globally as well as also within India. So 60% of the emissions which happens in the plant comes from valves, and out of that 60%, again the 60% of the emissions from a valve comes from its packing area. So what are the solutions available there? Like there are a lot of low emission enviro seal packings available, now which typically meets a EPA requirement of less than 500 ppm or less than 100 ppm requirements from the EPA requirements in the US, or and there are also other more stringent solutions available like bellow seals, where which even further reduce the emissions from the valve packing. And then there are also applications where typically sometimes there is no instrument there available, or you use single loop controllers which are powered by the process medium itself, like natural gas. Again, you have got low bleed controllers available in that aspect as well. There are also, we talked about low power requirements in process plant. Again, there are low power actuators now are available, electrical actuators, which can be used for such applications. The other solutions which you see at the bottom, like, some of those specific valve types, like a gate valve, they by inherently, because of its design, they have got higher emissions. So, there are triple offset butterfly valves which are available, which can be, replaced, which can replace those gate valves or ball valves, which means they give only lower emissions to the environment. The other advantage is, like, they've also got lower footprint in terms of weight and space, which means, again, the costs are, much lower in terms of, the total install cost, total cost of ownership is much lower. Then, if you move to the right, like, knife gate valves, those are typically used in mining industry or, metal industry, typically on slurry applications. And some of the existing designs have got the sleeves leakage. The process leakages leaks through the sleeves. So with the new designs, like, it's completely covered body, there's no leakage to the environment. So again, some of those solutions are already available, like, where you can reduce the leakage and emissions and discharge to the environment to meet the new stringent environmental regulations. Then if I move forward, like, from a manufacturing standpoint, now we talked about IoT. So IIoT is a subset of IoT, as we all know. So again, the how do we improvise or innovate the valve manufacturing as such? So in my mind, like, you have got IIoT, which will play a definitely a big role going forward in terms of the factory of the future. There will be robot assembly, like, there may be robot assembly of products and instruments, which could happen in the future. Use of RFID for tracking components, so that, there is much more better accuracy and end-to-end tracing. Virtual reality and inspections, additive manufacturing. So all those will play a big role in the future valve manufacturing process. Some of those are already being adopted and used and provided by some of the manufacturers. Again, the benefits are, like, you are eliminating a lot of repetitive actions which are done by humans, which typically causes errors. You're eliminating those. Then again, lower carbon footprint, in terms of, reduced, use of power, end-to-end connectivity and traceability. Of course, increased productivity and also improved quality and increased safety. And then again, it becomes a bit more sustainable, if you once you start, electric mobility, LED lights and things like that, in a reduction in carbon footprint overall. And then if you, again, if I move forward with some of those specific topics, let's talk additive technology. Like, again, these are being employed by some of the valve vendors already, where, there are two segments to it. One is to use, as we all know, most of the valves have got body and bond, which are castings. So to do the molds for the castings, we can employ 3D technology, which reduces the lead time to develop those patterns of the molds. That's one option. Then the other option is use what we call LPBF, which is, laser powder bed fusion technology, which is like a micro layer welding process of manufacturing, where where you can also the beauty is that, like, you can make complex geometry designs from that process. So, again, if I look at this, like, from historical methods to the new latest additive, one, you're compressing your lead times, so improved speed. You're improving your reliability of that particular component or product or part, because the number of part counts comes down, the number of weld joints comes down, so improves the reliability of the particular component. And then in the manufacturability, in the past, probably some complex geometry in a trim inside the valve, which had intricate flow passages or intricate geometry, which was difficult to machine earlier. Now with 3D printing, those are possible. So again, like, these are all new developments which are being done. And it also reduces the reject rates in terms of, manufacturing. Again, new advancements which are being already employed. Then the other thing, which has really taken off since COVID started last year, like, what we call virtual inspections. Again, with all the travel restrictions which were in place, this has really become now the norm. Somebody sitting even outside of India can inspect his product, which is being built by the valve vendor in India, by virtual inspections. We could use either fixed high definition cameras or mobile cameras to show various tests and inspections in terms of positive material identification, dye penetrant test, the standard hydro seed leakage functional tests, valve signatures, paint impacting, all that remotely for somebody who's sitting not visiting the valve vendor's factory. So again, the benefits are reduced travel, logistics costs, obviously increased productivity, again speed, and increased safety because they're not sending people to to test witness all these tests at the valve vendor's facility. A lot of benefits. And this is now the norm in some of our facilities, and I'm sure even after the pandemic is over, this will be the norm for the future. So, and again, with the latest technologies available like RealWare, which are being employed now, the resolution and as well as and the imaging which you can get remotely also has tremendously improved. Okay. Then if I move forward, we talked about IIoT, again, there is a lot of aspects here as well in terms of wireless monitoring, analytics, as well as connected services. So again, I want to talk about three subjects here. So if you look at the right-hand slide, which is safety or pressure relief valves, again, those can be remotely monitored now, either using acoustic transmitters, pressure transmitters, or position transmitters. Again, if there is any discharge is happening from that safety valves, either by motion sensing, sound sensing, or by pressure sensing, you can get that feedback back to a control room, which is getting the data back wirelessly. And then the valve, the vendors, experts can also look at analytics based on that and give feedback as well as maintenance actions to be taken. The same applies for pumps as well. You could monitor a pump remotely. It could be a vibration monitoring on the pump, a cavitation monitoring, seal monitoring, or in a strainer if the strainer is getting clogged. All those can be monitored using wirelessly, and again looking at the data back and looking at the analytics, and then you can take advanced action. Same for tank integrity and protection as well. You could monitor the valves as well as other products on a tank for better integrity management of the tank, in terms of whether it's blanketing gas, optimum usage. And again, all this what provides is enhanced safety. It reduces emissions to environment, and also it's protecting your asset. Yeah. Again, all these technologies are currently available. And if I move forward, again, the same thing for control valves as well as safety instrument system valves or ESD valves. Similar methodology like we saw in the last slide. You have got with the usage of smart digital valve controllers, which has got multiple sensors embedded. You can sense a lot of valve parameters as well as which can be fed back to either to the end user who is monitoring that, or it could also go to the valve OEM specialist, then who can interpret that data. And then what the beauty is that you can take advanced action before an event occurs. Again, what we call predictive maintenance, which enables a plant to operate much more reliably and safely. And it also improves the uptime of the plant and also improves the performance of the plant. Again, all these capabilities are currently available and also being used by some of the users as well, here as well as globally. So again, a lot of changes which has happened. So I just want to summarize now. So if I, like I mentioned, the valves have been in play, being used right from the last 2,700, 2,800 years, right from the Roman era, the usage of bronze valves for controlling water. Then the industrial revolution and development of control valves, actuated valves, advent of sophisticated design, manufacturing process, use of special materials, all has happened in the last couple of centuries. And then again, late last century, we started using digital valve controllers, which gave remote communication capabilities for control and SIS valves. And then going forward, like I mentioned, decarbonization, reduction of greenhouse gases, human health and safety, digital transformation, IoT are going to be the priorities and focus. And then the valves and actuators will definitely evolve based on these priorities.
Hello.
In terms of how we are manufacturing those products and how they are being installed and used on site for improved reliability, safety, and performance. Thank you very much.